Previously, on 8051 microcontroller series, we have gone through the introduction to microcontroller, block diagram, and pin description of 8051 microcontroller. Today, we are going to see through RAM structure of 8051 microcontroller. Hi friends, this video series is presented by RLC-EEE. Without wasting our time, let's start the topic. RAM. RAM is known as Random Access Memory. RAM is also a type of volatile memory. That is, when a power supply is removed, the data stored in the RAM is lost. 8051 microcontroller has 128 bytes of RAM. It has an inbuilt 128 bytes of RAM. The memory location of that is going to start from 00H to 7FH. The memory location starts from 00H to 7FH. That means 7F means 127 plus 1, which we are going to get 128 bytes. So each memory location, that is each and every memory location, say 00H, 01H, 02H, okay, each and every memory location can store a data of 8 bits. Data of 8 bits, which we call it as 1 byte. Call it as 1 byte. So we have from 00 to 7F, we have 178 memory locations, and each memory location can store 1 byte of data, which we call it as 128 bytes of RAM. These 128 bytes of RAM are organized into 3 different areas. Those 3 different areas are register bank, which starts from 00H to 1FH memory location. Then we have bit addressable area, which starts from 20H to 2FH. Then we have general purpose area, which is from 30H to 7FH. That means we have the register banks, which occupies 32 bytes of data. It's a 32 bytes of data. Then bit addressable area, it has memory location from 20H to 2FH, which is of 16 bytes. Then general purpose area from 30H to 7F, which is of 80 bytes. Which is of 80 bytes. The first 32 bytes from the memory location 00H to 1FH are organized as 4 banks. Those banks start from bank 0, then bank 1, bank 2, bank 3. Each bank has an equal share of 8 bytes because we have totally register bank of 32 bytes. It has been divided into 4. So we have 8 bytes. 32 divided by 4, we have 8 bytes equally divided. These bank addresses are start from 00H to 07H for bank 0, then 08H to 0FH for bank 1, same as it is 10H to 17H for bank 2, then from 18H to 1FH for bank 3. Now we'll see with the detail of each banks. For bank 0, it has a memory location from 00H to 07H. So for each and every memory location, the name has been given. Like we have in colleges, we could have been seen like a student will be having the name. Along with that, there'll be an university seat number or the register number, same as it is. For these memory locations in the register bank, for each and every memory location, the name has been given. For example, for 00H, we call it as register 0 or R0. For 01H, we call it as R1, 02H, R2, same as it is, it continues. For 07H, we call it as R7. Okay, that is register 7. This is for the bank 0. Same as it is, bank 1 memory locations also has names. Now for the bank 1, it starts from 08H to 0FH. This 08 memory location is also called as R0. Then 09 memory location is also called as R1. Same as the memory location increases, this R0 R1 also increases. So for 0FH it is R7. This is for the bank 1. Same as we have it for bank 2. In bank 2, it starts from 10H to 17H and the names start from R0 to R7. Then for bank 3, it starts from 18H to 1FH and the name starts from R0 to R7. Now the thing is, like for bank 0 also we have R0, R1, R2, R3, R4, R5, R6, R7. Same for bank 1, same for bank 2, same for bank 3. Now the question arises, if we are going to say collect the data or move the data from R0 to A, which R0 should be selected? Or move the data from R1 to A, which R1 data needs to be selected or the memory location needs to be selected? Whether it has to select the memory location of bank 0 or it should select the memory location of bank 1, bank 2 or bank 3. Because if we consider R0, this R0 is been named for 00H and it is also been named for 08H, then for 10H, 18H. Now from these, if I am going to say move the data from R0 register to A, in these 4 memory location, microcontroller has to choose which memory location it has to pick. So to overcome that, it has a register select bits which have been available in PSW, that is program status word. Okay. The detailed explanation of this register will go in the upcoming video. Now we'll see only with the RS1 bit and RS0 bit. We have 4 working registers or 4 banks. So to select those 4 banks, we require minimum 2 bits because 2 power 2 is equal to 4. So we have RS1 bit and RS0 bit. When both are 0, if we are going to store RS1 is equal to 0 and RS0 is equal to 0, then bank 0 will be selected. If I am going to make RS1 is equal to 0 and RS0 is equal to 1, then bank 1 will be selected. Then 1 0, bank 2, 1 1, bank 3. So if I say move A comma R0, move A comma R0, and if the PSW register RS1 and RS0 bit both are 0 0, then the data from the memory location 00H will be copied to A. Data location from 00H will be copied to A. Same as it is, if I want to access bank 1, then I need to change the value of RS1 and RS0 accordingly to this table. According to this table, if we are going to change the values of RS1 and RS0, then we can choose the register bank from bank 0, bank 1, bank 2, bank 3. Next, now we'll see with the second area of the RAM, that is bit address area. Bit address area is from memory location 20H to 2FH or 16 bytes of data. The main feature of these locations are each bit of data in these locations can be altered individually. We'll take 20H memory location and see its difference with register bank and general purpose area. Now we'll consider 20H memory location to understand the bit addressable area. It is not necessary that the information to be stored always it should be in the form of bytes. We know each and every memory location can be can store the value of 8 bits, that is 1 byte. Instead of that, if we need to store the data in terms of Boolean, say only 1 bit has to be stored, then we can make use of this bit addressable area. We can make use of this bit addressable area so that we are going to save all other bits for other purpose. We can save these bits for other purpose. We'll take with one example and we'll go through it. It will be easier to understand. Assume I have two variables x and y. Now the condition of this, if x is greater than y and if x is less than y, this data has to be stored in the memory location. This condition has to be stored in the memory location. This can be stored in two ways. One is by using the full memory address, that is byte. I can store it as 00h or I can store it as ffh. Instead of using 8 bits, I can use only 1 bit of data, that is Boolean value. If x is greater than y, I can store it as 0. If x is less than y, I can store it as 1. I can store it as 1. So that all other 7 bits are being used for other purposes. We can use it for other purposes. Okay. This is what the main use of bit addressable area. This bit address, that is accessing each and every bit, is not possible in all the memory location. It is possible only from 20h to 2fh in the RAM. 20h to 2fh in the RAM. These numbers indicates the bit address. This number indicates the bit address. Before we'll proceed with the topic, friends, the theory content of these videos are frequently updated in our website www.rlc-eee.com. You can find the link in the description also. If these video contents are helpful, press like and the share button. You can subscribe to our channel to get notified for our upcoming videos. Okay, we'll continue with the topic. We saw like the addresses for 20h, same as the bit addresses will be incremented. That is, we can see over here for 20h 0th bit it is 00h, for 20th 8 bit it is 707h, same as it is for 21 location it starts from 08h to 0fh, then for 22 location it starts from 10h to 17h. It goes on from 00 to 7fh. That is, we have 16 memory location. 16 memory location. Each memory location can have 8 bit of data. So totally we'll have 16 into 8, which is of 128 bit address. We can store 128 bits of data or can be accessed in bit addressable RAM. Can be accessed in the bit addressable RAM. Now we'll go with the general purpose area, that is from 30h to 7fh. That is the RAM area from 30h to 7fh constitutes for general purpose area, or it is allocated for general purpose area RAM. It is going to have 80 bytes of data. 80 bytes of data are allocated for general purpose area. That is, we know that RAM is of 128 bytes of data. In that 128 bytes of data, 80 bytes is for general purpose area, 32 bytes is for register bank, and 16 bytes is for bit addressable area. This general purpose area can be accessed by byte address. It can be accessed by byte address. The advantage of using this memory location is that the data access is faster compared to off-chip RAM. The data access is faster compared to off-chip RAM because this 128 bytes of data are inbuilt in 8051 microcontroller. In the next video, we'll go through the special function register, program status word register, and later we'll start with instruction sets. Friends, if you have enjoyed the learning, click the like button and share with your friends and well-wishers. Connect with your social media platforms. Thanks for watching. We'll continue our journey of learning in the next video.